Hello and welcome to lesson 3.5, Getting It All Together. What we're going to do today is we're going to use all our skills from advanced functions and calculus of vectors in order to sketch functions like this. Now most of the textbook uses are polynomial functions and or rational functions. Those are the ones that we'll focus on. Very few times do they use square root functions, and later on we'll use sinusoidal functions and exponential functions when we get to those, or mixtures of. So we're going to start out by analyzing just the function itself. So the first thing you should do is analyze f of x. That means you should determine what kind of function you have. So this is a cubic function. With a positive leading coefficient. That means as limit as x approaches plus infinity, f of x is going to equal infinity, and limit as x approaches negative infinity for this function f of x, that equals negative infinity. We can write these end behaviors that you wrote in advanced functions in limit notation. You can also notice that this function is, well, we can check to see if it's even or odd. So substitute negative x in, I get negative x cubed plus 6 times negative x squared plus 9 times negative x. That gives you negative x cubed plus 6x squared minus 9x. So it's neither, you'll notice that f of negative x does not equal f of x, neither does f of negative x equal negative f of x. So therefore, neither even nor odd. Well, we could also notice that based on this function, we can find that zeros, and if any different, we can also find the y-intercept. So I'm going to set this equal to 0. Notice I can common factor out an x. So that means I have zeros at 0 and x equal to negative 3. So there we've analyzed all our function f of x based on all that we know. We know zeros, we know end behavior, we know other things. We just don't know where maximums and minimums occur, what happens at any concavity at certain places, and whether they increase or decrease. We have a general idea where it increases and decreases, but we don't know exactly. So we'll look at that. So now the next part, we should analyze f prime of x. So first we got to find the derivative. Well, the derivative of that function is 3x squared plus 12x plus 9. And again, we want to find out when that's equal to 0. So I'm going to set that equal to 0 and solve. Common factor out of 3. Use my equation solving strategies. I can also factor this as x plus 1 and x plus 3, luckily. So that gives me two values of x equals to negative 1 and x equals negative 3, which I can put into an interval chart now. Okay, so now that gives me what f of prime of x is going to do, and therefore f of x is going to do. Okay, so it's a quadratic opening upwards, so that's going to be plus, minus, plus. So that means it's going to be increasing, then decreasing, and then increasing. So that means the point f at -3 should be a value that gives me something interesting. F at -1 also gives me a value that's interesting. Now please realize when you're creating these interval charts based on this information, if you do have a vertical asymptote, you can't include that value listed, just like you couldn't in advanced functions. And that means even if it's increasing then decreasing, doesn't mean you have a maximum. You got to check those points. So I got to check these points, -3 and -1 in my function. So I'm going to substitute those in. -3 cubed plus 6 times -3 squared plus 9 times -3. Okay, that gives me a value of 0. Oh, yeah, this is one of my zeros. Ooh, I forgot to notice that. And if I substitute 1 in, sorry, -1, that gives me a value of -4. So here I have, therefore, the point -3, 0 is a local maximum, and -1, -4 is a local minimum. Because if I know the shape as well, it's going to look like some kind of S-like shape, because it's a cubic function. It'll look something like that. I know that we're not going to have any absolute maximums or minimums, so I don't need to go into that. Okay, so let's choose. I want to choose a different color. I'm going to choose purple now. Okay, so now we're going to analyze. Double prime of x. Okay, so I also know where my function is increasing and decreasing, so I'll remember that. So second derivative for this function gives me 6x plus 12. When does that equal 0? Okay, well that's going to be easy to figure out. At -2. Okay, so let's create an interval chart again. We're looking at values less than -2 and x value is greater than -2 for our second derivative. And that's going to tell us what our function is doing. So f double prime of x is a linear function increasing, so that's negative to positive, meaning it's going to be concave down and concave up. So again, I have a general idea of what the shape looks like. And because of that, ooh, I had a complete full other page there. Okay, f at -2 is equal to, let's substitute -2 into that function. Because the other two values being 0 and -4, I'm going to guess it's probably -2, but I'm not going to take the, it is, cool. Okay, complete waste of this page, so I might as well write something down there. Therefore, the point -2 and -2 is a point of inflection. Now, instead of having two separate interval charts, I have seen people put together one interval chart between the two of these. So you could do that, and let me actually show you what that looks like if you did. So you would put down x less than -3, -3 less than x less than -2, -2 less than x less than -1, and x greater than -1, since those were the values of interest here. You would analyze f prime of x and f double prime of x to give you f of x. So we knew from our first one we had zeros at -3 and -1. So it was, oops, I completely forgot. Oh yeah, it's quadratic. So plus, minus, minus, plus here. And then the second one was a linear function, increasing, so this was negative, negative, positive, positive. So that means it's, for x values less than -3, it'd be increasing and concave down. So draw something that's increasing but concave down. Then the next one is decreasing, concave down. Next one's decreasing but concave up. And then the next one's increasing, concave up. So you have a general idea what the shape looks like, and therefore you don't have to make two different interval charts. So with this information, we can now sketch what this graph looks like. So let's take some points here, draw some points. Some points of interest were 0, and let's say this is where -3 is. So let's say this is where -2 is, and -1, and -1, -2, -3, and -4. Okay. So you just have to put a few values in it. As this is a sketch, it doesn't have to be perfectly accurate. Okay, so some points of interest were our zeros. These are our zeros. Okay. -1, -4. So -1, -4 was a point. -2, -2 is also a point of interest. We know it increases after this point. We know that it decreases. Sorry, okay, so starting at from the very far left, we increase up to the value of -3, and then we start decreasing after that. It's all concave down, and now it's going to be concave up after this. So start concaving up, decreasing still, now increasing, concave up, right through, and there we get a general idea of what the function looks like using all the information we know. And thus concludes our lesson.